Yes. Okay. Yeah. Yes. Okay. Good afternoon. Yes. As I told you in the beginning of the lecture, I did synchronization chapter just 2 hours or something in one group. Uh, I will record that lecture for the other groups, and I will ask if I ask something, very generic questions, nothing hard to do. So I don't want to go further to that chapter because it is a little bit complicated. So uh, we don't have enough time to continue. So I will continue from memory management. So I believe that it will be better for you to also understand, and there are a lot of practical things, easy things to do, and it is an interesting chapter. Yes,
Which chapter?
this one, memory management,
No, you said that you
desynchronization,
signalization.
chapter 4. I will make an online lecture and put it to Moodle.
Four. Okay, we check it then.
Yes, but it is, I just say this is this is that, nothing complicated. Okay, we just started that lecture. I already did with that them, so I don't want to waste it, but uh, at least you can have an idea about synchronization. But we are not going further because actually the further topics is a kind of need some kind of advanced programming or this kind of other programming skills. So it is not necessary to continue to that chapter. Okay, our next topic is memory management. So in the beginning of the course, or in the beginning of the semester, we discussed what is memory management. Operating system is also responsible for managing the memory. I mean, which process will put inside, uh, is it full or not, or how much memory left. This kind of things is doing by operating system, and the name of the task is memory management. Hello. Okay. So what is memory? Actually, when we say memory, you can understand all kind of devices that can store something, permanent or temporary. When we say main memory, actually, we can understand that it is a random access memory or similar. That when we close the computer, everything goes. So here, computer memory can be defined as a collection of some data represented in the binary format. As other memories or other things that we can put something in it, we are saving it in binary format. What is binary? I mean, by ones and zeros, or you can say there are two different states or phases. Okay, sometimes it can be saved by using magnetically or electrically, this kind of things. So it may change. Hello. Okay, so we were also saying that uh, random access memory as a main memory because it can directly interact with the CPU. And also we discussed it before. Okay. What is memory again? A computer device that is capable to store any information data temporarily or permanently is called storage device. So we can say that memory is our generic name, but because of we are saying primary memory to RAM, also sometimes we are saying memory. So it is a little bit confusing, but the memory is a generic name of all kind of storage devices in computer. So yes. Okay. Uh, yes, I can continue, I think. As you see, memory can be cache memory. Do you know what is cache memory?
No.
Cache memory is very small but very fast memory. It is coming with CPUs and central processing units are just holding the just using that to make the necessary calculations, just putting the necessary results into it. It is very fast because it should be enough for CPU's speed, but on the other hand, it is very small. Okay, and primary memory is RAM, and secondary memory, for example, SSD or hard disk, this kind of devices are called as secondary memory. Okay, how data is being stored in a computer system? Let's check how we can store it by using binary system. What is a binary system? Binary system consists of zeros and ones. So when I say decimal system, that's the system we are using in our daily lives. It is consists of 10 digits starting from 0 to 9. Binary system consists of 2 digits, only 0 and 1. For example, binary system can be called as base 2. Decimal system can be called as base 10. For example, we can say there is also base 8. Base 8 means there are 8 digits in that system, starting from 0 to 7. Okay, so why they choose binary system for computers? Because in the beginning, when they design computers, they have two things to do. I mean, like opening and closing a switch. Just they have two states. So to manage the computer, they use these two states. And from the beginning to now, they are using the similar logic. That's why we are using binary. Actually, we are not giving computers zeros at once. We are giving the signals or similar things to a computer, but two different types of signals or something like that. So computers can understand us, or we can manage the computer. Okay, do you know, for example, how to convert a binary number to decimal or to decimal binary? Who doesn't know? Anyway, if we need it further, I will show you. But here, as you see, let me to trying to find something. I can't do it. Anyway, okay. Can you see the binary code right side? It is the binary representation of decimal numbers. Look, this is the simplest version of using binary codes in computers. In our keyboards, we have letters, numbers, other symbols. Yes. So there is a table which is called as ASCII code. That ASCII code is using for take the binary code of the numbers and just convert it to digits or numbers, any character, or just the opposite. Okay, so when I press a letter of my or any key of my laptop, for example, if I press capital A of my laptop keyboard, it will send to the computer the binary code of A. What is it? It is 100001. Okay, it is 65 in binary. And of course, what I am expecting when I'm pressing A, I am expecting to see on the screen letter A. Yes. So computer is also converting that number, that binary number to just letter again. So this is how it happens. We are not going to do it in detail, but just I just want to have an idea about it. Okay, so we can say that computer converts every data into binary language first and then stores it into the memory. And also, if we are going to just use some data, during computer is working, it is 100%. We can sure that it is just loaded into memory. So while we are saving, loading into memory, we are always just saving as zeros, combination of zeros and ones. Okay. So the representation of integer I is equal to 10. Okay. Here I can say that also you already heard about 16-bit, 32-bit, 64-bit of addressing. This is because the systems are using, for example, 16 bits or 32 bits or 64 bits for doing something. So if the, for example, in old computer systems, integer integer variable needs 2 bytes to store something. Okay, it doesn't matter if you store 5 or very big number, it doesn't matter, but it is allocates you 2 bytes. It is something like that. I am renting houses, okay, and house capacity is 10 people can stay at the same time. But only one person can stay, 5% can stay, or 10% can stay. Okay. So this is 2 bytes means the total memory that the computer is arranging or operating system is arranging. Okay, if it is 2 bytes, it means how many bits? 1 byte is how many bits? You know?
16.
1 byte.
1 byte 8 bit.
Yes.
No.
So
2 byte.
2 bytes, 16 bits. So if we arrange 16 bits, it means we have 2 bytes. It means we have 16 bits of memory. So, and let's say I said I want to locate 10. So my line is this. So this is my I variable, and I'm going to put inside an integer value. Okay. So if we start from bit 0 to bit 15, in memory I have to locate them like this. Okay. So let me to make this example, just converting this one to binary. So this is decimal. I'm going to convert it to binary. How I can do it? I can make like this. I can write the powers of 2, 2 to the power of 0, 1, 2, 3, for example. I can write 2 to the power of 4. I have to find a number that's smaller than or equal to my basis, first of all. So if I write here 1, this number will be 2 to the power of 6, 4 is 16. So this number will be at least 16. So it is bigger than my number. So how can I do it? The next number that fits my
It's
8.
1.
So
0.
this is 0 because if I put here 1,
It will be
12.
12.
Okay.
So 0,
0.
1.
And this is 2 to the power of 1 is 2.
2 plus 8, 10, 1.
And this one
0.
is 0. So this is the base 2 conversion of my number. So I will write here 1, 0, 1, 0. And the rest of the bits will be 0. But sometimes I think you are using, for example, signed or unsigned integer. When you use signed integer, if you check the limits, you will see that it is less than unsigned integer limits. Why? Because if a variable is signed, the leftmost bit or most significant bit or leftmost bit doesn't matter, is using as signed. So it is saying that this number is positive or negative. For example, if it is 1, it is positive, negative. If it is 0, it is positive.
Yeah.
So,
like if we have for this one -10.
-10, yes, right. It will be, and if my number is signed, this will be -10. That's one second. So if it is again signed, but it is positive. Signed integers can be take positive or negative, so it can take positive. So this one will be positive. But if it is unsigned integer, we are using this part as a part of the number. Okay. So actually, I don't know how I can pass to the other side, because I'm also recording the lecture, because very few students came. They will ask to me to explain these things again. That's why I'm recording. But if you check, for example, signed integer, short integer, values is something like minus 32,000 to plus 32,000. But unsigned integer, short integer, it is 64,000 something. That's why this is the reason.
So the only thing, if you want to write negative number, you use to the 50th bit here to make their one.
Yes, yes, but your variable should be no signed variable.
Signed variable.
Yes.
You assign it a negative number.
Yes, if it is signed by making this, you can one.
It means that this one is negative number.
Yes, yes. Okay, we can also discuss it next week. I will make a revision again. So normally in here, as I told you, in it is depending your compilers or systems, but now the normal value of integer is 4 bytes. It's very big. But the older versions was using 2 bytes. Anyway, it doesn't matter. It is easier to show you in integer, I mean in 2 bytes. That's why I showed to you. So this is the difference. Maybe I will next time I will give you a few examples and we can just do it by using examples. Okay. So yes. So as you see, in short integer, you don't need to say signed short integer. Short integer by default, it is signed. So its values can be minus 32,000 something to plus 32,000 something, because it is not using this most significant bit. It is using only this 15 bits. So actually, if you multiply, I mean, take the power of, 2 to the power of 15, actually, you will give that number to you. Anyway, so, and if it is unsigned, it should be unsigned means my value cannot be negative. So it will start from 0. So as you see, my range is now positively increased by double. Here it was 32,000 something. So think about that. If you write here integer I or short integer I, 32,768. It will not store that one. It cannot store. But here it can easily store because of it is positive. Okay. So need for multiprogramming. We discussed this one as well. Okay. As you know, the programs, processes are always executing in main memory. Do you remember what was multiprogramming? What is it?
multiple programs when you see the web.
Multiple programs can we can put into RAM at the same time. Okay. So and we are going to check how they made it first, the multi-programming, because before only one program or process we can put in the memory. So what does this mean? CPU can execute only one process, and when that process needs for some input-output operation, CPU will become idle, or it needs to just put it to the secondary memory, put another one. So it will take a lot of time. Okay, so the size of main memory affects degree of multiprogramming to most of the extent. So size is very important, because what does it mean? How much we have more memory means we can put more processes. So if the size of the main memory is larger than CPU is larger, then CPU can load more processes in the main memory at the same time, and therefore will increase degree of multiprogramming as well as CPU utilization. So actually now we will see how the utilization increasing. We have a formula. So we will see how it is increasing the utilization. So we know that if the memory increases, memory size increases, degree of multiprogramming will increase. But at the same time, CPU utilization will increase. What is CPU utilization? We can use our CPU more effectively. So let's consider. So let me to write this formula first. It is easy. Because in the first one, it is not explaining well. It will be in percentage. It will take the yes, we can say, let's say n. And this is input output time. So in the first example, if my process size is 4 megabytes and main memory size is 4 megabytes, so it means I can fit only one process to the main memory. So to find the utilization, I will subtract from 1 to P, which P is the time for process does input output, but it is in percentage. It means the 30% of the time will be wasted for input output. Okay, something like that. So it is in percentage. But I am here to find it. I am just subtracting. If it is, for example, 70%, if it is 70%, I will take 0.7. Okay, so I will subtract from that. And because of number of processes that fit into main memory is only one, so it will be 1 minus p over 1 is p again. So 1 minus 0.7 is 0.3. So you will say utilization
30%.
is 30%.
What is the P?
Huh?
The P is the tab for input output.
Yes, think about that. We have a process. Okay. Oh, let me go. We have a process, and it is saying, okay, this process approximately needs 40% of input-output operation and 60% of CPU.
Utilization.
Not utilization. I mean, 60% of the time will be wasted for CPU execution, and 40% will be wasted for input-output. So it will not use all the time CPU. Okay. So another one.
So
Yep.
the time required for input output are we doing?
Here, yes.
Yeah.
Yes, of course. Time required. Not time required. The percentage will be given. One time I didn't give it directly, and I just asked something like you asked to me, and no one did it. Maybe I will solve, if I can solve that kind of examples, I may ask that type of question. I understand you. Okay, let me to continue. So we increase the memory size. Let's say it is 8 megabytes. So process size is 2. So how many process we can put inside the main memory?
2.
2. So my formula will change 1 minus p over 2. Okay. So it is not in parentheses, all of them. I mean, not parentheses over 2. Just like this one. Or so this is p over 2. This one. 1 minus p over 2. Okay. So in this case, just they gave the same numbers to just compare from the previous one. So P is again 70%. So the 70% of the time will be wasted for input output. So in this case, 0.70 over
Square. 0.7 square. Well,
Yes.
0.
So it will be what?
1 minus 0.49.
So 0.51.
51.
So utilization
51%.
actually very straightforward. I mean, I think you get it.
Yeah.
Okay, so for example, let's do it by yourself. Let me to give another example. Where is it? let's say
Process size, 2 megabyte.
memory size 15 megabytes. Let's say input output time and find CPU utilization. This one needs calculator, but you can make by your phone.
This one equal 1 minus 0.5. P to power.
Everyone can follow what we are doing, or so let's do it. 1
minus 0.5. 0.5 to the power.
how many
5. 5.
I can fit 5 5 process. So if I will take this one over 5.
Yes.
So can you give me this number?
0.025, I think. 1 minus
Huh?
0 point.
Are you sure?
No, 5 times 5, 25, 0.8.
You will multiply it 5 times.
Yeah. Wait a minute.
25. 25.
6.5.
No one can calculate by your
0.03125. 3125.
Okay. So 1 minus this. So can you just subtract it from 1?
Wait. Wait.
$0.96875.
6,
0.968.
0.9,
6,
yes,
8. 1, 6, 8, 7, 5, not 1.
6, 8, 7.
5.
Okay, that's enough.
8 equal to 7, 6, 8.
6, 8.
Yeah, 6, 8, 7, 5.
Okay.
Yeah.
So in percentage, it is approximately 97%.
97%.
So as you see, the size of the memory is increasing, and process size, if it can fit more processes, we can put more, I mean, our CPU utilization will be better. Okay. So okay. By the way, I'm also recording the lecture, but it's, I don't know how much time we have. Let's stop the. We have how much time we have?
2 hours. 2 hours.
Yes, no, I am asking about. Okay, I'm ending this session and I will open.